So coded.
Next one is Tobias.
Yeah. Hi, my name is Tobias, and I want to talk about Docker. All right. So, what is Docker? Docker is basically a REST API written in Go, which sits on top of LXC. It manages build packaging and lifecycle of containers. LXC, a little background, is a lightweight kernel-based virtualization technology. So it also does network configuration. It does distribution of images. It uses UFS, which is a copy-on-write file system. I might talk about later. And it was open sourced by .cloud in March 2013, so it is kind of a new project. All right, so LXC, as I said, is operating system level virtualization technology. It is pretty lightweight, and the basic idea is to manage multiple network and process bases on a single host. For example, Heroku uses it to power the dynamos. I hope I'm not wrong. So at least one Heroku guy here. So scream now if it's not true. And it's basically a change root on steroids. So what are containers? Containers in the Docker context are designed to be lightweight. That means no full operating system VM virtualization. In the perfect world, there should only be one process per container. So that means you don't have a SSHD daemon on the container. You don't have. You shouldn't use direct file system access because there is no such thing as state. You can go around with that, but you should live without state. You shouldn't run like cron next to an application server inside a container. And you also shouldn't have a syslog daemon running inside the container. And you normally also don't put any monitoring inside the containers. Everything like cron, syslog monitoring, all that should be done on the host system, so from outside of the containers. But you probably do want to monitor your containers. And they are created to be thrown away, basically. So you don't fix containers. If there is a configuration bug in your container or any other problem, you just throw the container away, you put a new one, create one from a new image or whatever. But you don't SSH into them and like look at log files and stuff. All right. So Docker provides you with some commands to create images, to tag images, to distribute images, to start containers, stop containers, remove containers, and remove images. I talked about containers and images. Images are basically the blueprint of containers. So they're like a stack of binaries you use to launch new containers. And to build images, you can use a Docker file, it's called, similar to Makefile, Procfile, Gemfile, etc. And it's a really, really lightweight scripting language to create images. It is basically a linear batch script. So you basically put a couple of lines in, and those lines are executed on the container. And after each line, that step is committed, and a new step is basically built on the previous one, which is kind of similar to how Git works, basically, because if there is a change in the Docker file, everything which is common is reused, and there is basically a branch being introduced in the images. Bit hard to explain, and they're also cached. And this is how a basic Docker file looks like. First of all, you provide from which base image you want to build the new image from. Then you do. In that case, I enable universe, run a apt-get update. install Redis server, create the data dir, insert some config files, expose a port, and run Redis server basically. And maybe I have a little bit more time for a demo. All right, so hit the IP address. Pardon? Too slow. So, better? Okay. So the whole talk is basically served. What? The other way. Nice. Okay. So basically, the whole talk was served by a container, which I just created. The Docker file for the container looks like this. Let me see. So it's pretty basic. So first of all, all right. First of all, I enable universe. Then I run get update. I install Ruby and Git core. Right then. The next slide is on. No. Yeah, because I created a little Sinatra app to serve the talk. Then I clone a repository, install bundle, and run the container. And with that one, I can launch as many as I want. The networking here, the local port 80 inside the host system is mapped to the local port in the container. But I can also access the container directly through a. Is that 1 minute left, or is that finished then? All right.
So sorry. Thank you so much.
Yeah.